Hi everybody. As you guys know, we've got a maths investigation that we're going to be working on over the next little while, and you can find that here in the classwork tab in Google Classroom. This is where you'll be uploading your draft when you get that done. Still a little while until we do that, but just so you know. And the actual task sheet itself you can find here. So I hope that you've downloaded it and had a read through it now. That's basically what it looks like. There's a couple of functions that you're going to be researching, and you're going to also try and use those functions to model some real life in inverted commas situations. All right, so that's what we're getting ourselves in for here. Now, how can you write this up? You've got to process it in some way, and most people are going to use Microsoft Word. That's absolutely fine. But I just want to give you another um, option here that you might want to look at if you're feeling brave. So that's LaTeX. Now, I'd just like to take you off to a fantastic website, which is called archive.org. I don't know if you've ever been there before. It's worth putting in your list of links because it's an absolutely fantastic website with lots of up-to-date papers that are published in physics, mathematics, biology, a few other fields. Yeah, a lot of the stuff here is going to be pretty complex stuff, and that's not really important for our purposes right now. What we care about right now is how do the pros, the professional mathematicians, how do they put together their papers? Well, we've gone into functional analysis, papers on functional analysis, and we've just had a look at the first three papers. So what do we notice? I might blow this up a little bit here. Well, first thing you see is that we've got a title, and you might think, well, that's completely obvious, but you'd be surprised how many students write a paper and they don't put a title on it. So that's a good way of formatting your title. Next thing that we see, who wrote this thing? So many papers come in from students anonymous, and you should be proud of the work that you're doing. You should be putting your name there front and center and saying, look, this is my work, this is something that I've done. Then we've got an abstract here. Now, it's not absolutely essential for your paper to put an abstract in, but you might want to do it. You might want to just put a short paragraph explaining what's this all about. The reason why abstracts are put in these sorts of papers is because we're dealing with quite complicated stuff. No one's got time to read all of these papers. Very often, all that gets done is people have a look at it, they look at the abstract and they say, okay, well, I've seen a paper that was on this sort of stuff. If you're really into that particular thing, you might want to keep reading. But that's why we put that there. By the way, I know that teachers are going to tell you don't use personal language in your scientific writing, but we is the exception to the rule. We and our, those types of inclusive language are fantastic. They're a really good way of getting some buy-in from the reader. The reader feels like they're involved in the process as well. So you'll see a lot of that. We prove variance of Werner's theorem. Notice how they're not saying, in this investigation, what I'm going to do is blah, blah, blah. That doesn't read so well. Instead, just tell it like it is. We're going to prove the variance of this theorem, blah, blah, blah. And then we get into the introduction. And then there's going to be other sections. We'll put some theorems in there that might be relevant, and so on and so forth. When you go down to the bottom, which I'll quickly scroll all the way down, so if that's a little bit blurry on your screen, you can see why in this paper we needed an abstract. At the end, we're going to have the reference list. Okay, and notice what they're doing here. They're using numbers for their references. And in the paper, like for example, here we've got reference number 16. And so the reader can go, that's a bit fishy. I better go and have a look at that. Is that really the case? They can come down here and they can go, hey, that's really what that paper said. And not only that, I've learned something new. This is a really cool paper. I might use that in my investigation when I write my investigation. So specific claims for should be backed up with specific references. I should know where that information has come from so that I can either believe it or not believe it. Does that make sense? Okay, so that's the first paper that we had to look at. Next paper, what do we notice? Well, it's kind of funny. It seems to be formatted in exactly the same way. So I'll go up to the top again. Let's go right up to the top. So this is in boldface type in capital letters. This is in boldface type in capital letters. And then we've got the author's name down here in capital letters. And then we've got the abstract here. It kind of looks like they're using the same software to do this. And in fact, that's what the case is. Almost all of the mathematical papers, physics papers, etc., that get published using the same piece of software, and it's not Microsoft Word. Okay, so if we come and now look at the third one, same deal. Same layout, title, author, abstract, introduction, and then we go on from there. Because it's always the same every single time, we're making this difficult to understand material a little bit easier to understand because we know what to expect. We know that there should be a title there. We know that there should be an author there. We know that there should be an abstract there. We know that the introduction comes next. Okay, so even if you're using Microsoft Word, try and ape this format. Try and, as much as you can, write like a pro. Okay, now, so where does that all fit into what we're going to be doing in today's video? I've got a template here that I've put together that you may want to use. Okay, again, this is not essential. You don't need to use this software. I've got to tell you, it's not straightforward. You know, there's a learning curve here. In the past, though, I've had really good results from students who have taken this on. And then once they get their feet wet, they start realizing, hey, it's not so bad actually. And in fact, after a while, you'll find it easy to use the Microsoft Word. Um, so anyway, it's called LaTeX. There's a couple of aspects to it. You've got to download and install LaTeX. That's a process in and of itself. And then you need something to interact with LaTeX. I like to use TeXmaker. TeXmaker is my text editor that I like to use. There's many other examples as well. So I'm going to upload this template folder here. And in the folder, you can see I've got a picture here of Leibniz. I've got a picture here of a graph, it looks like. And then I've got some other stuff as well. The thing that's most pertinent to us right now is this .tex file. Okay, that's a text file right there. And that's what I'll give to you. And up to you whether you want to use it or not. So what do we notice here? Well, it does look very different to Microsoft Word, that's for sure. The thing with LaTeX, its big advantage really, in my opinion, is the fact that it separates the content from the presentation. Okay, so when you're playing around with Microsoft Word, that's what you see is what you get editor. And so as you actually type stuff, it appears there on the screen. And that can be a blessing, but it can be a bit of a curse as well because you'll spend a lot of time mucking around with this margin and you click a button and it does all this crazy stuff that you didn't want it to do. LaTeX, that doesn't happen. Okay, LaTeX set up in this sort of way. You write into the text editor part and then you compile your code when you want to see what's happened. And you should be compiling on a regular basis, in my opinion. So anyway, what do we see here? Well, we're going to use something called the AMS Art document class. It's right here, AMS Art. This is an article, it's for writing mathematical articles like we've just seen, and it's put together by the AMS, the American Mathematical Society, I think it is. We're going to use A4 paper naturally, and we'll use 11-point type, okay? So that's all good so far. Now, there's a few packages which I'm going to include here. I'll give all of those to you. You can see that I've actually got those right here. There are the packages. We'll talk more about that later, maybe. And then this is where you would put in your details. So I'm Peter Gent. This is the college that I'm at, and this is, you know, where I'm located. Obviously, you would change that to suit your needs. Once we get out of this sort of preamble section where we put all the nuts and bolts, the next thing is we're going to actually start writing our document itself. And that comes in this bit. So we're going to begin our document right here. And then we're going to end our document right at the end. You've always got to begin things and end things. Okay. This is where I've put my abstract. It's short, sharp, and shiny. And this is where I've got my introduction section, and there's a few other sections as well. Okay, so let's just have a quick look at that right now. I'm going to compile it by clicking on this little button here. And, you sort of do a bit of a pray for rain dance there and hope that it compiles properly. But in this case, you can see that it's compiled correctly. Okay, now what do we notice? It looks pretty similar to this. Okay, the reason being is because this is what they use to write their paper. All right, now you might not want this stuff here, the open access college stuff. That's fine. There are other ways of putting in your address and your details. So you might want to get rid of that. Let's just delete that. You can see it's still there though, okay, because I haven't compiled the code. But if I compile the code now, all of a sudden, there it is. So that's kind of how it works. You can see the abstracts come out in this way. And let's go back and look at their abstract. Oh yeah, small caps. And it's sort of indented a little bit right there in the middle. It's in a smaller typeface point size as well. Okay, but I'm not having to worry about, formatting it. That would be quite a process if you wanted to do that manually in Microsoft Word. Here I'm just saying, well, this is an abstract, so I'm going to put it in an abstract environment, and it will do all the heavy lifting for me. So this is why professional mathematicians favor this software, because you don't need to muck around once you learn how it works, and you just keep a template which you've used before, basically. Then it's very quick to put this stuff together. Now, this is a mishmash of all sorts of different things here. We're talking about probability, but your surge and logistic functions investigation has nothing to do with probability. I'm just trying to kill two birds with one stone here because we're about to start studying probability. So you can see here, I want to give you a few different ways that you can set out your maths. So if you want to write maths in line with the rest of the text, like I've got here, that seems to work well. Then you would just put it in these dollar signs. And you can see in my text editor, it turns green. That way I know, oh, I'm in maths mode there. Okay, so anytime I'm writing some maths, I want to put them in dollar signs, and that will just make sure that my X's are in italic type and space things out just right. It's going to look $1 million if you do this. Sometimes though, you want to break off your text and display it. Instead of writing it in line, you want to write it on its own line. And in that case, you might use this environment. So I've used / open square bracket, and then to close the environment / close square bracket. Okay, and you can see it's essentially the same sort of thing, but because I'm using a slightly different environment, when I compile it, it's going to put it on its own line, and that can be a nice thing. You also might want to label your equations. So you can see here that this equation here has a number 1 at the start of the line. Okay, that's a labeled equation. Now you might prefer to have right equation numbers. If that's the case, then you would come up here in your document class options, you'd say right equation number, rec no, like that. And when you compile it now, it's going to put all those numbers over there on the right hand side. That might suit you better. It's totally up to you. Interestingly, you see what I've done here? I've referred to equation number 1. You can see that it's equation number 1, and I'm calling it equation number 1 to bring my reader's attention to that. But I haven't put a 1 in here. I've just come in here. This is the equation that's labeled, right? I've put a label on that equation using that sort of trick there. And then when I want to refer to it, I go / ref, and then in curly brackets, I tell what I want to refer to. Well, I'm trying to refer to this label right here. Okay, so that's pretty handy because that's going to automatically get the numbers right. I might put 100 equations in my paper, and I don't want to be keeping tabs of which one was number 1 and which one was number 2. After all, I might be copying and pasting and cutting and changing their position. That would be a nightmare. Well, LaTex is smart enough to know, okay, well, that's got that label, so that's the one I'm going to refer to. It might be equation 1, or I might have to change that to equation 10 or whatever. Okay, another thing that you can do in LaTeX, which is possible in Word, but not easy, is to line up your equations. So you can see here that I'm lining up some equations at the equal symbol, which is what you want to do. Well, that's easy to achieve using the align environment. The trick is to use the align environment, and then you just need to say, where am I aligning? And the special character that will tell where you want to align is at an ampersand symbol right there. Okay, or you might have some reasoning. So you might, you know, no, let's leave that for now. We can come back to that some other time. Okay, we can also label our aligned equations. The only difference here is that instead of using what I call an align star environment, okay, that has no numbers, this time I'm using a plain align environment, and then I will get numbers. Normally, I don't like to have those numbers there for just run-of-the-mill equations. I don't think they're sufficiently important to do that. But you might, some papers, they just label every single line, and that's also an option. So that's how you do that. And just in general, with LaTeX, anytime you use a star, that normally gets rid of the numbering. So you can see here, let's see if this works. Where's the intro? So introduction right here with no number. So I'm going to get rid of this star now, and I'm going to recompile. And you can see now I've got number 1, introduction. And that might suit your style a little bit more. It's totally up to you where you go with that. I'm just going to leave the numbers off though for now. In fact, let's go and see what the pros did. So they're using numbers, and numbers. Well, maybe I'm in the wrong. Maybe I should be numbering my sections. Who knows? Anyway, it's up to you. It's not a big deal. Oh, another thing I just wanted to point out is you can see here in this set of equations, my final answer is k equals 1 over 12. And obviously, I get the same answer down here, k equals 1 over 12, because I'm doing the same calculation. But here I'm using a tiny fraction, a t frac, instead of an ordinary frac. So that's the notation, by the way. If you want to put in a fraction, /frac, in the first set of curly brackets, that's where you put your numerator. In the second set, that's where you put your denominator. Couldn't be easier, once you get the hang of it, that is. What else do we see? Well, here I've emphasized some text, I think. Up here. So I've emphasized the word inline. Okay, and let's have a look up here. Yeah, sure enough, inline is emphasized right there. Okay, so that's that. Anyway, you can keep these starting materials, and then you can change them as you see fit. You don't need to memorize all of this stuff. You can just change them. There's obviously a lot of great resources on the internet as well. So if we go to Share LaTeX, for example, that's a good one. You'll find lots of info about how to put your stuff together. Where is it? Documentation, maybe? LaTeX basics. So creating your first LaTeX document. How does the preamble work? How do you put the title in? How do you put in abstracts? Stuff like that. If you've got a question about things like how do I italicize text, how do I put it in boldface, the internet is your friend. There's going to be so much information. And yeah, look, it's tricky when you're first getting your head around it. But slowly but surely, it all starts making sense. And then that's a wonderful feeling when it just kind of feels right. Okay, so in your paper, you're probably going to have a section on surge and logistic functions. So let's go and check that out over here. We can see here that I've got just some dummy text. Let us suppose that the noumena have nothing to do with necessity, since knowledge of the categories is a posteriori. Sounds like gibberish, right? This has come from a philosopher called Immanuel Kant. And in order to get this type of dummy text, I'm just using the command /Kant and I'm saying which paragraph would I like. If I wanted to have paragraphs 3 to 4, for instance, let's just change that. And when I compile it, now I get some different gobbledygook here. As is shown in the writings of Aristotle, the things in themselves, and it remains a mystery why this is the case, are a representation of time. Okay, it's actually surprisingly useful having dummy text when you're writing a paper, because you can see how the thing's going to look on the page. And in fact, on that note, that's one of the great things about LaTeX. So it sets out nice, beautiful black blocks of text on the page, and it's been designed very, very carefully. There's a lot of stuff which is subliminal, but they've put it together so that it's going to look like a professionally typeset document when you compile your code. It's going to look absolutely beautiful. Most people won't realize why it looks so good, but they'll just have this vibe about it. They'll think, oh, there's something about this that's different from something that's done in Microsoft Word. And in particular, your moderators at the end of the year, they're going to see this paper with a big A+ in it, and they'll say, I've got no concerns with that. That looks pretty fair to me. Okay. So anyway, I'm waffling a little bit. So when you're doing mathematical writing, you want to make definitions, you want to put in theorems, you want to be proving theorems, all that type of thing. So let's look at this one on whatever this stuff is. Here's a theorem. This is Wiener's Tauberian theorem. Okay, and it's got some stuff. There's a bit of integration going on. Here's another theorem. Great. And normally theorems aren't just put in there without any proof. Normally there'll be some proofs that come at some point. Here's a proposition. That's basically a theorem that's a little bit less important. Okay, let's have a look at this paper. We've got a definition here. We've got a theorem here. Okay, this is done in a very, very formal sort of way, etc., etc. And what's this one? This is on quasi-analytic contractions. Sounds good. You can see how it's set up like that. So there's a theorem, and here's the proof that they're going to offer. Okay. So anyway, if you want to work out how do you put theorems into your LaTeX document, it's very easy to find online, and I can help you with that. So here's the definition I've got for the surge function. Let a and k be positive real numbers, and let f be a function defined as f of t equals a t e to the minus kt, where t is a non-negative real number. So you can see I'm giving the rule, and I'm also giving the domain. You need both of those things, strictly speaking, to have a function. You can see that I've actually numbered this one and I've labeled it. So when we come to this part of the code, I've got my equation here, and you can see that I've labeled my equation. I should really tab that across. When I'm in an environment, I'd like to tab across. It adds code readability. So later on, I can refer to that in this way. So the thing that I'm referring to is in curly brackets right there. Okay. Now, obviously, you can do calculus nicely in LaTeX. Here I'm using the Leibniz notation, DDT. Now, how did I achieve that? I achieved that by using diff, and then upstairs I've got nothing, and downstairs I've got a t. If I wanted an x there, I would make it dx dt. Do you see how that works? But I want that one blank, so I'm going to leave that numerator, let's call it position blank. Okay, so I've done a bit of differentiation there. Okay, now what else do we need in a good quality maths paper or any piece of scientific writing really? Well, it's good to have figures. Figures are a good thing because it will help us just, it's like a mental break. It's very intense reading through this sort of stuff. So if you've got a nice little picture, that can break up the flow and it can really help. So how do you add images? It's pretty easy. If you've got the package which I'm going to give you in this template here, all you need to do is you need to find your image. So this is an image of Leibniz. I've gone on the interwebs and I've found this lovely picture of Gottfried. Okay, and you see how I've labeled it. I've called it 0-Leibniz.jpg. Okay, 0 just so it filters up to the top of my list of files here. I want all my images labeled with a 0 out in front so that they make their way up to the top when it's ordered. Okay, so I come in here, you can see I've got a figure environment, so begin figure, end figure. I'm centering this image. If I don't have that, I'm just going to comment that out, by the way, by putting a little % sign there. If I compile that now without the centering command, oh, actually this is smart enough, believe it or not, to just know I've got to put that in the center. So that's a peculiarity of the AMS art document class, I think. So that's good, but I'd put it in there anyway. Then I say, which graphics do I want to include? So / include graphics. What's the scale? So this is only 16% of its real size. If I put that all the way up at 100%, then it's too big. Obviously, you wouldn't want an image that big. So you've got to play around with it a little bit. I'm going to put it, let's call it 16%. There are other ways of scaling your image, by the way, that you can find online, and I can help you with that as well, if you'd prefer to do it another way. Then underneath, we've got a caption. Importantly, we know where this has come from so that the next person can come along and say, hey, I want to print that out and put on my wall. Where did you find that? Well, here's where I found it. It's not something that I came up with myself. Someone else has put that out there, and now I want to sort of credit that. And I've labeled it. So here's how I've labeled it. That way I can refer to that figure in this sort of way. And I don't have to write figure 1 or figure 2 or whatever. It's just going to know which number it is because it's smart like that. Okay, so include some pictures. You also want to include some tables. Well, here's the table from the task sheet itself. So in your task sheet, I give you some data, and you're going to model these data here with a search function and work out, is a search model a good fit for this or not? So how did I make that table in the first place? Well, I use LaTeX, and this is the code that will give you that table. So we're in a table environment, we're centering it, we've got a caption, we're labeling it so I can refer to that later on, and then we've got this information here, that's putting the actual table there itself. So what's all this LRRR and stuff? Well, that's saying that in the first column, that's going to be left aligned. And then for the remaining 1, 2, 3, 4, 5, 6, 7, 8 columns, those guys are going to be right aligned. Okay. So for example, if we center align that last column, just to see what it looks like, it's going to look a little bit funny because, you know, when you add up figures, you always put the tens in the same position, the hundreds in the same position. I guess I missed the units as well. Do you see what I mean? So you want numerical data should be right aligned in tables. All right. So that's how you put in tables. And if you want to put in your own table, you can copy my sort of syntax there, or you can go searching on the internet and you'll find lots of information on how to write a nice table. So how are we going to put in our graphs when we do this? Well, one thing you could do is you could use something like Geogebra. You could plot this graph, or these graphs in this case, take a screenshot of what you end up with, and then use the include graphics command and put it in that way. So we're going to put in the picture just in the same way that we put in the Leibniz picture, except this time we're coming up with the picture in the first place. We're developing that picture, taking a screenshot and putting it in. That's probably the sanest way to go. If you are going to go down the LaTeX path, you're biting off a lot, guys. You've got to understand that. It's totally possible, and I'll show you good examples of student work. But you've got to know that it's not trivial to do this. Okay, so this would probably be a good way of putting your graphs together for this report. If you really want to push yourself, then you can actually draw those graphs using LaTeX itself, so not using Geogebra. So here's one that I've drawn with LaTeX with a package called PGF plots. Okay, and again, that will be in the preamble, so you won't need to find that. You'll just need to use my template here. And this is basically how it looks. So these graphs were made using the PGF plots package. Well, that's pretty clear where that relates to. You can see that PGF plots is in like a typewritten typeface there. I've got that by /text TT. And then what do I want in the typewriter typeface? I want PGF plots in there. Okay, I've labeled it so I can refer to this image later on. But how did I actually get those graphs in the first place? Well, I had to use something called a ticks picture environment. Okay, and so I'll begin my axis, I'll close my axis, and this is some of the information that I want. It's put up a nice little legend here. So that's pretty cool. And it just looks $1 million. And one of the great things about this is a vector graphic. So it's infinitely zoomable. You know, you can keep zooming in here forever and it's still going to maintain that perfect clarity. Whereas this guy here is going to lose some of that sharpness the more you zoom into it. Now that may or may not be something that you care about, but it's just a cool little thing. Okay, so that's all that. One other thing that I guess I should just point out is that I've throughout this put in a couple of footnotes. Now footnotes aren't for everyone, and I think sometimes they're a little bit overused, but I wanted to show you how they're used anyway. So where's an example of this? Okay, the product rule is sometimes referred to as Leibniz's rule. Let's see if we can find that. Here we go. So we're talking about u primes and v primes. If we can find that in the text, let u equal at and v equal e to the minus kt, then u prime equals a and v prime equals minus k e to the minus kt. So you can see where those kind of match up with this stuff here. Right, on the product rule, that's where I've got my footnote. So it says thus, by the product rule, there's the footnote. Okay, and you can see how I've written that into the text. I've gone /footnote. What do I want my footnote to be? Well, that's the stuff that I'm going to be putting into curly brackets. Okay, like that. So again, it's the same idea. It keeps repeating. Once you get that idea, you'll find this very, very easy to use, this software. Oh, one other thing that I just noticed. Good code should be very readable. That's a real focus when we're doing LaTeX. We want it to be readable not only by us, but also by other readers. And importantly, we want it to be readable by us in 5 years' time when we come back to it. So there might be some stuff that we just want to drop a hint to us, our future selves. And how are we going to do that? Well, we comment text. So anytime you can see here on line 56 of my code, the first thing that we see is a %sign. So that's telling LaTeX, look, this is just for the human user. Don't actually typeset this. That's just it's a comment in the code. All right, so where are surge functions? Yeah, so this bit here is the dummy text from Immanuel Kant, okay? But at no point does it say that gives us some dummy text. Okay, the fact that it's commented out here and in gray is the hint that that's not going to compile. Now, suppose I uncomment it by getting rid of that % symbol. Now, when we compile this, it will actually go in the code, but obviously that's not what we want here. So I'll comment that out again and recompile. Very, very handy little trick. Okay, one last thing. AMS art isn't the only document class that's around. Okay, so for example, it's very, very common for people to use just the plain article document class. it's going to look pretty similar, but there are some differences. Okay, and the important thing is we don't need to keep rewriting our code. We just make this one little change here and then everything's going to change automatically. So this is more like the vanilla way of setting things out. I kind of like the article document class. In many ways, I prefer it to the AMS art document class, but it's personal preference. It gives us a slightly different title. And you can see that these become a bit clearer now. So my introduction, because that's a section heading right here, it's in boldface type and it's a larger point size. For me, it's a little bit easier to navigate through the document if it's formatted in that way, but it's really a personal preference. I guarantee you though, if you go poking around in archive.org for long enough, you're probably going to find an example of just using the article document class. That's another AMS art one. That one's, you can see there, that one's been done with just a plain article document class. So they've got that like that. But the point is, it's all LaTeX. Okay, so definitely that was information overload, I'm guessing. Like I say though, it's worth having a go at. It's not essential, but if you're feeling brave, have a go at it. I'll be here to help you with it. And I think you'll find it very, very satisfying to use this piece of software. Okay, guys, I think that's a good place to wrap things up for today.